All right, so what we're doing is we're going to talk about vectors. And so, again, whatever I write down, you write down. So, oops, not that big, though. Distance. And displacement. Okay. So what I've drawn on the screen is a vector. Okay. So a vector is an arrow that represents a value, and there's a fancy word we use for that called magnitude. And a direction. Okay. So a vector is an arrow that represents a value and magnitude and a direction. So I'll say this from time to time. I'll say this is a scalar, this is a vector, this is a scalar, this is a vector. I'll slide that up so you guys can see it a little better in the back. Okay. So let's draw some vectors. So this vector here can represent 4 meters. And we'll talk about the difference between vectors and scalars. Now if I draw another vector, This one, because it's twice as long as the other one, is going to represent 8 meters. Okay? So Mr. Adams walks 4 meters and then he walks another 8 meters. How far did he walk? Okay. Yeah, everything that's on the screen, that's what you got to write down. Well, in this case, you would just add them up because they're both going in the positive x direction. So the way that you would approach this is you have to remember that going to the right, whoops, I don't know why that's there. Going to the right is positive and going to the left is negative. So this is really 4 meters plus, because this is a positive 8 and this is a positive 4. Plus 8 meters, and then your final answer would be a positive 12. Now I'm writing the positive number because that actually determines how far you're going. And so if I were to figure out, if I were to draw that vector, it would literally be the sum of, well, let me do this. That final vector would be the same length as the two combined. So this is kind of what you would do for your homework today. So what I'm trying to show you is that we can represent motion like velocity or acceleration or the amount of force applied to an object by using vectors. The more intense or the greater the magnitude of the displacement, right? The longer the arrow. Okay? So let me talk to you, we're going to talk about the differences between displacement and distance. So the first thing is distance versus displacement. Did everybody have all the arrows and stuff drawn, or do I need to go back? Did everybody get that? So I'm going to draw two little things here. I'm going to draw one little So this is going to be my start and my finish. So I'm going to start here. And this is where I'm going to finish. So I'm going to go for a little walk. Okay? So there's two different things. The first thing I'm going to talk about is distance. So if I start here and I go way over here, and then I come around here, and then I come around here, and I come around here, and I come around here, and I come around here. Let's say we measure that. And let's say that Mr. Adams walked 123 meters. Okay? That would be my distance. That's how many steps, if you were to measure based on, and distance means that we follow the path. And then the next thing that we're going to talk about is the displacement. The displacement is like a shortcut and it's always a straight line. Okay.
What is the thing about distance?
Follows the path. And so in this scenario, the distance might be 25 meters. Or not distance, the displacement. Okay. By the way, we're almost done with our notes. All right. So you do gotta sketch this out, and then after this we'll pretty much be done. So think of this almost like the XY plane, but going up is north, going down is south, right? So this is north, going down is south, going to the east is to the right, and going to the west is to the left. Oh, that's a horrible. And this is my start, and this is my finish. And if you need rulers, I do have some rulers over there, but you could just sketch this out. It doesn't have to be perfect. Okay. So we're going to do some distance, and then we're also going to do, we're going to track displacement. So let's track my movement. From the start, I'm going to go 1 unit, 1 meter east, right? So I'm going to write that down over here. So the first thing I do, let me change the color on that. We need a little bit darker color, I think. We'll do red. So I'm going to go from here to here. That's 1 meter east. Okay. Then from there, I'm going to go up 1, 2, 3 meters north. Okay. So that's 3 meters north. Then from there, I'm going to go 3 meters east again. I'm going to go down 2 meters south. Then I'm going to go 1 meter west. Then I'm going to go 1 meter west again. Then I'm going to go south 3 meters. Then I'm going to go 1 meter east. Now, if I want to calculate the distance, you mean scroll up?
Sure.
You can't see the stuff on the bottom, right?
Right.
Okay. The distance, I'm just going to add all these up. So I have 1, and I'm just getting this from I'm just going to add all these numbers up. So I have 1 plus 3 plus 3 plus 2 plus 1 plus 1 plus 3 plus 1. That's how many meters I've moved, right? So if I add all the ones, I have 1, 2, 3, 4. 4 plus 6 is 10. 10 plus 2 is 12, plus 3 is 15. So the total distance that I moved is 15 meters. Okay? So that's my distance. But now if I want to find displacement, that's just going to be a straight line from the start to the finish. And the distance between those two things don't really matter. Well, how did I get there? Well, really, I went 4 meters east and 2 meters south. Now in this class in science, sometimes we work with distance, but a lot of times we work with displacement. Okay? Now here's an interesting thing that you're not aware of. I can actually do all the math by making a positive and negative number. So if I say that if I do south versus north, going north would be positive and going south would be negative. If I say west versus east, east would be a positive number and west would be negative. So my first one is 1 meter east, so that's a +1. My next one is 3 meters north. North is positive, so that's +3. I do another 3 meters east. Oh, shoot. I hate when that happens. So another 3 meters east would be +3 over here. We did 2 meters south, so that would be going down, so that's a -2. 1 meter west, west is negative, so that'd be 1 meter. Another meter west would be 1 meter negative, and then 1 meter south would be -3. So if I add these up, 3 minus 3 equals 0, so I've got -2, which gives me my 2 meters south, right? And then over here, I have 1 plus 3, which is 4. That's 4 minus... Did I miss some? Oh, you know what I missed? One more going east. So we got one more going east. So really I have 5 minus 2, which would be 3. Oh, you know what? See, good thing I did this. I have a +3, so it should be 3. But if we count this, you know, Mr. Adams must count. Look, 1, 2, 3. So it's actually 3. Well, that's a good catch, I guess. So make sure you change that to 3. And so there's a couple different ways to do it. So on your homework, you don't have to do all this positive and negative stuff. If you were in my AP Physics class, I'd make you do that. You just have to sketch out on a grid, on a piece of paper, and figure out where you land. Okay? And I'll ask you, what was the distance that you traveled, and what was your displacement? That's all you got to practice. We got one more thing to do, and I will show you that in just a second. Can I slide up a little bit? Okay, this is the last thing you have to write out. So I have two vectors here. And so when we label the vectors, we usually give them a name. So this could be vector A, and this could be minus vector A. So when it comes to vectors, when we say plus or minus, notice that they are the same length, just in opposite directions. That's it. That's all there is to it. Okay? That's all you have to do. And then one more example. I'm going to draw one more vector up here. And we'll call this one vector B. So sometimes you'll have, like, let's say A represents an airplane flying in a very specific direction, okay? So we're going to do vector addition real quick. So this is A. It's an airplane flying at a certain speed. And then the wind, we'll call B, is blowing in a different speed in a different direction. And so if I label these two, I would call this A plus B. So A plus B means something. So this is vector A and this is vector B. So if this is a plane and this is the wind, what direction does the plane actually go and how fast does it actually go? Well, the way that I figure that out is we do a thing called the resultant vector, and the resultant vector just goes from this tip or that tail to this tip. Okay? And so my resultant vector we would call, usually we call it R. So you would call this R. So A plus B equals R. Okay, one more example and then we'll be done. Oh, why did I put B, you guys? You guys got to check and tell me what I'm doing. So if this was an airplane going in this direction, and this was the wind blowing in this direction, this is the actual velocity of the plane. It'd be a combination of those two vectors. And R is usually the resultant. And that's basically it. Now, the other thing you could do is you could actually, how do you think B minus A would look? Well, B minus A would look like this. So if I wanted to do B minus A, I'm basically going to do the same thing, except I'm going to take B and then I'm going to take the opposite of A. So I'm going to take this. This is my B, and then I take the opposite of A, which is this one right here. And now I draw this tip to tail. So this would just be B. And then this is negative A. And then I just draw a line between the both of those. Again, I start at the tip, or the tail of the first vector, and go to the tip of the last vector. And we'll give this one a different name. We'll call it we'll give it a different color too. So we'll say that that equals C. Okay. So then you have a completely different, and so you can think of like a plane flying to California and a plane flying back from California. The wind's blowing the same way. In one case, the plane would actually be going slower. And then in another scenario, the plane will be going faster. So I'm going to zoom out so you can see all of that stuff. That's the difference. Okay. There you go. So this is A plus B. This is B minus A. And that's all you need to do your homework. Okay. Does anybody have any questions on this stuff?